Hi everyone. After knowing about three-phase induction motor construction and the rotating magnetic theory, we move to the next topic, which is working principle of the three-phase induction motor. This is a very interesting topic because you have to know about the rotating magnetic field theory to know about the working principle. So let us go with the next topic, continuation of this working principle. So in continuation with the rotating magnetic field theory, I had said you. So this rotating magnetic from green it went to blue, from blue it went to red, from red it went to green. The total flux is being rotating in nature. That I have mentioned you. When the total flux is rotating in nature, it rotates with a speed that is called as a synchronous speed actually. So the synchronous speed is the speed at which the total flux rotates, and that is designated by ns. Here it is written small n and synchronous. Mostly in majority of the books they take it as capital N into n with the suffix of x. So it is given by 120 f divided by p. F stands for the frequency and p stands for the poles. So it is a synchronous speed. So this is the speed at which the flux starts rotating with the total flux value or the magnitude of 1.5 times of phi. That's what we discussed in rotating magnetic field theory concept. We'll just go with that and we'll just do some calculations where the number of poles are 2, 4, 6, 8, 10, 12, and the frequency is 50 hertz and the frequency is 60 hertz. All of us know in India we use the frequency as 50 hertz, but in Western countries they use frequency as 60 hertz. So it doesn't matter, it depends upon the way we produce the electricity. So number of poles are 2, and by using this formula, ns is equal to 120 f by p. It is a very important formula to do the problems based on synchronous speed, slip, and rotor field and all those things. So this speed equation, synchronous speed equation, though it looks very simple, but it is very important. So here ns is equal to 120 f is 50 divided by p, so it becomes 3000. Actually here it becomes 3600. I'm substituting number of poles 2 and the frequency as 50. You can see the frequency as 50 and the number of poles are 2, so 2 goes here by 60. 60 into 50 becomes 3000. In the similar way we get 3600. The frequency remains the same here, but the number of poles starts increasing. From 2 poles it goes to 4 pole, from 4 pole it goes to 6, 6 to 8, 8 to 10, 10 to 12 actually. So whenever the poles increases, you can clearly see that the speed keeps on decreasing. The speed decreases actually. So from 3000 it went almost to half, 1500, then to 1000, then to 750, 600, 500. Here also you can see half, and then 1200, 900, 720, and 600. So this is how, just in order to make you aware of this formula, the synchronous speed is equal to 120 times of frequency divided by the number of poles. I have used this calculation. So we'll go with the next topic. So this is the working principle of the induction motor. So these are the steps which are involved, and you can see there is a lot of theory involved in it to make you understand. So to make it simple, I have just used this flowchart. In exams you can write down this theory, but actually this is how it works actually. In order to make you remember so that you can write it in the form of sentences, you can use this. So what do I first do? I give electrical. This is a three-phase induction motor. I give electrical energy. I give three-phase supply to the stator, and this three-phase supply, what it does, it passes. So there are magnetic poles and flux is produced in the stator, and this flux, how the flux will be, the flux will be rotating in nature. So where we studied about the topic called rotating magnetic field with a constant value of phi m, and they rotate with a speed called ns. Ns is called as synchronous speed. Now here it changes. This synchronous speed, though I have not written here, it's very important. The rotating flux, what it happens, it passes through the air gap and goes and cuts the conductors and passes through the conductors actually. So whenever a conductor cuts a magnetic field, EMF is induced. So here the conductors are stationary, but the flux is rotating in nature. So whenever a conductor cuts a magnetic field, they are cutting the magnetic field, and now EMF is induced according to Faraday's laws of electromagnetic induction again. So whenever this EMF induced, I said about construction of this induction motor, I said about squirrel cage and slip ring, they're all closed circuits. Whenever there is an EMF induced and the circuit is being closed, there is a passage of current. The current flows. The current is flowing in the rotor conductors. See, step by step effect actually. So one after the other, effects keeps on going. So there's a current in the rotor conductors. In the conductors, in the armature conductors, you can say, or in the rotor conductors, there is a current. Now what happens, this current carrying conductor is placed in magnetic field. Magnetic field is all around it from stator to air gap. This current carrying conductor is placed in magnetic field. It experiences a force. That force is the mechanical energy to make a rotation. So that's why, the current carrying conductor is placed in magnetic field. It experiences a force and it starts rotating. The rotating force is called as torque, and whenever it rotates, we have the speed. So these are all topics are being given here in this working of induction motor, which are expressed in a form of step-by-step procedure, like a flow chart for your easy understanding. This is all about the working principle of three-phase induction motor. And so once it rotates, the electrical energy which I gave here, you can see the top is electrical energy, and finally the end is the torque or mechanical output. That is the basic principle. So many things happen which you cannot see it with a layman's eye, but these are all the things which happens in your motor, especially in three-phase induction motor. So this is the one which we are going to do. And whenever, and that's how it rotates. And there is a slip. There is a concept called slip, which is very important. Now, as I said, the rotor also rotates. The rotor rotation is given by N, and the rotating magnetic field is given by synchronous speed. So what is slip? They both are not same. The flux speed and as well as the rotor speed are not same. There is a small gap in them. There is a small lag in them. In your own words, it's a lag in them. So that lag is called as slip. Ns minus N divided by Ns is called as slip, where Ns stands for synchronous speed and N stands for the rotor speed actually. The slip is also very important. Basing on this slip, we talk about torque slip characteristics, and also torque equations comes into the picture. So with that, hope you understood the working principle of induction motor in a better way. I convey thanks to all of you. Thank you very much. And if you have any doubts, you can post in the chat box. Thank you all of you. Have a great day.